So hey guys, welcome to Clear and Crisp Coding, and in this video we would be discussing the solution of CodeChef Lunchtime 2020 gold mining problem. This was a really interesting problem, but this was as compared to its difficulty, that means the number of position it appeared on the contest, it was relatively easier. So now here is the problem statement. You can read the problem, but if I explain the problem to you in simple terms without missing any important point, then the problem is something like this. So chef and chef who are gold miners. So they have n mines numbered from 1 to n, and for each mine contains GI gold. That means GI is a value it would be given to us, and chef would take AI days to completely mine it, and chef who will take BI. That means if individually each of them would mine, they would be taking AI and BI days respectively to completely mine this value. That means completely take this value. So and there is also this part given, that means that each of them can start working at any part of the day and end working at any part of the day. That means they are working independently. So basically a chef can start at the work in the beginning and of the day and leave it at the middle of the day. In middle of some day it is given. So basically the main problem is here that at each point both of them know what gold mine each of other is working on. So that means they can choose the gold mine in which other was working, or they can choose a different one also. So each of them basically want the maximum amount of gold. So and both of them acts optimally. So this is really important. This is the what will form the base of our greedy approach, and we are given this input and output. So basically if we see that on the the GI gold is present in the ith mine, and chef take AI days to mine it, and chef who takes BI days. So if we see basically, for let's just see for this example only, it would be very clear. So since it is given that both of them know that on each day who is which mine is other person working on, so he can go to their mine also and work, or he can just do another mine. So basically if we see this example, this would be definitely making things really clear. So here if we see that there are 3 mines, the first mine has 10 gold, second has 20, third has 30, and chef take this 1, 2 and 3 days to complete this, and this also take these days. So let's see that let's see of only one case, that there is only this mine and chef take 1 and this take 1. So what could be the answer for this case? That means there is only one mine of G10, and one person take 1 days to completely mine this, other take 1 day to completely mine this, and both of them are working on it. So after that this would be equally divided in this ratio, 5 and 5. So when the work would be completed and both of them work together, so these would be also getting 5, this would be also getting 5. And now let's see of this is 20 and 2. So here also both of them will start together, then this would be divided equally, so 10 and 10. So now and just we see this one for 30, this is 2 and 1. So basically if they both started together, so this would require 2 days to do the same amount of work which this would be doing it 1. So the ratio it would be divided in 1:2. That means, so if chef takes X amount of gold from here, then at the same time, so suppose if they started at the same 0 time, so chef has taken X, then chef who could take 2X. How is that? Because the speed of chef who is twice. So this ratio would be definitely there. So if chef has taken 1, then chef who could have taken 2. So what would be the value after 1 day? It would be 1/3 into 30 for chef, and 2/3 into 30 for chef, which is 10 and 20. So this was the answer for this part also. So now if we see that if they work on same mine at the same day, then each of them will getting the amount of gold from each mine in particular proportion. So but if on one day if we say that, let's consider this only, chef did not work, only chef who worked. So this value, the amount of this would be 0, as chef did not work, and chef would get 30. Chef would get 30. And what we want is that we want to maximize both of them. So by doing this, that means chef not working and chef working, we will be reducing this. So this was the main point of the question which you need to be emphasized, that by not doing work in one day only and doing in some other, that means we would be giving overall to this person and this would be getting 0. So this is reduced, even though this is maximized, but this is reduced, and we have to maximize both. So at the same time, if the chef also worked on this, then he could have extract 10 and chef would have 20, even though this is not the maximum, but in this case this also is not the minimum. That means chef can also extract the maximum. So if, and it is given that they can work on each of the mine independently. So this is one entire question, this is one entire question, this is one entire question, and on one question we have seen that if a person worked and other person did not work, then the person who did not work would be losing. That means if chef, this person did not work, then he would be getting 0, and the optimal answer is for this is to get a 10, which is getting reduced. So this is not possible. So on each day both of them have to work because they are thinking optimally, and this would be always valid. So the answer to this problem would simply be that we have to divide GI, we have to divide GI in the ratio of AI and BI. Okay, so now let's get to the code for better clarity. So here was the code. So we are just inputting this input, and then if n is 1 in the ratio, so the first person would get the goal of that day would be B upon A plus B, and the second person would get A upon A plus B. So this would be the value which each of them would be getting according to this ratio division which we just did here, according to their speeds and all the other factors. And if n is not 1, we are just doing this for all values and then printing the answer. So this was a solution. This was a totally greedy approach. We just have to focus on this part, that was both of them know in which mine other person is working, and they both want to gather the maximum amount of gold and find out the maximum amount of gold which they want to find if they both act optimally. So that means they both would not leave any chance of making gold. So if a day they won't take a day off, they won't be working always against each other and getting the maximum. So this was the question and this was the solution. So if you like the video, do give it a thumbs up and subscribe to the channel, as I would be posting more competitive program material for that contest and also for the other contest. Thank you guys, thank you for watching.